do a little bit of review from algebra, just from algebra. And if it was me, if you want to copy this down, you can. It's not really necessary. But if I give you a problem such as this, okay, we'll do a really simple one. X plus y equals 10, okay? X plus y equals 10. Nobody here, myself included, can give me the answer to that problem, okay? You can't, okay? You remember thinking, sure it is. 5 and 5. 5 plus 5 is 10. Yeah. Couldn't it be 6 plus 4? Sure. Could be 1 plus 9. How many ways can I add up numbers to get 10? An infinite number of them. Okay, even something like 4.1 plus 5.9. If you throw in decimals, there's an infinite number of solutions. Okay, you can't solve that. Nobody can solve that. Okay, because there's two variables. Okay, if there's only one variable, you'd only need one equation. But if you have two variables, in order to solve it, you need two equations. So if I give you something like this, 6. So what this is saying is, give me two numbers that add up to 10. But when you subtract them, you get 6, okay? And some of you might, if you have to think a little bit right here, but some of you might be able to come up with this answer right here. Yes, sir?
8 plus 2.
Say it again?
8 plus 2.
8 and 2. If x was 8 and y is 2, I'm writing that like this. X equals 8 and y equals 2. Now, how come the answer is not 7 plus 3? Those add up to 10. They don't subtract to make 6. How come the answer is not 7 and 1? 7 and 1 subtract to 6. They don't add up to 10, okay? 8 and 2 are the only answers that add to 10 and subtract to 6, okay? That is the answer. Now, you did that in your head? I'm assuming you did, okay? What we're going to be doing, you definitely cannot do in your head, okay? You can't. If you can do them in your head, you're in the wrong class. We need to send you off to some university and be in a college math class, okay? Now, how you could have done it, you could have done it on paper. You did it in your head. You didn't need to do it on paper, but you got to know the way to do it on paper because, again, you won't be able to do this in your head. What you can do, if I was to give you this example I give, if I gave you this right here, let's say, let's do, here, I know this isn't true, but what the heck. You and your brother are twins, okay? So let's say that Ko and Neil, myself and Mrs. Neil are the same age. We're not. I'm actually like a year or two younger than her, okay? But just pretend. And I'm not going to tell you how old you are, okay? And not that it's like, embarrassing, but just you don't need to know, okay? And I don't know how old Garrett is. I'm guessing he's 16, maybe 17. I don't know. But it doesn't matter. It really doesn't matter. And we're just pretending that Grady and Garrett are the same age, okay? We're just pretending. So if Ko and Neil are the same age, whatever that is, and Garrett and Grady are the same age, whatever that is, I could add my age and Garrett's age and get a number, and I can also add Mrs. Neil's and, did I say Grady? That's Garrett. I can also add Mrs. Neil and Grady's age and get a number. What could you say about those two numbers? They'd be the same. Whatever they are, they're the same. If this was 40 and 40, and this was 15 and 15, they'd add up to 55 and 55, okay? So that's a huge thing that you need to understand, that when you have equations, if you add up the left sides and you add up the right sides, you get the same thing. So why do I bring that up? Well, how we could have done this is we could have added these two and gotten 2x, added these up, and they go away. Okay, y plus negative y cancels. Add up 10 and 16, 10 and 6 and get 16. Then we can divide by 2 and divide by 2, and x equals 16 divided by 2, which is 8. And then we plug that in to either equation. It doesn't matter. 8 plus what is 10? 8 plus y equals 10. We subtract 8 to each side to get y equals 2. Okay? Just like we came up with, okay? Phoenix said that a few minutes ago. And again, if you're going, well, why do I got to show all the work? This is easy. You can do it in my head, because they're not going to be like that later, okay? Let me give you a little more difficult question, okay? This is one that I anticipate most of you will not be able to come up with the answer in your head. If I gave you 3x plus 4y equals 11 and negative 3x plus 5y equals 4. I think that's what I want. No, it's not. Let's see. Oh, I want 7. Yep, that's what I want. Okay, so this is saying, in everyday language, it's saying, well, I take some number and times by 3, I take a different number and times by 4, add them together, you get 11. I don't know what that is. And then I could take that same number that I had here and times by -3, and that same number here and times by 5 and add them together and get 7. That's a jumble, okay? So what we could do is this. We could add these up again. If I add these up, 3x and -3x add up to 0. They're gone. The y's add up to 9y. These add up to 18. Then we divide by 9. We divide by 9. Y is 18 divided by 9, which is 2. Is this problem done? No. How come? Got to find x. Which equation do I have to plug it into? Either one. It doesn't matter, okay? I'm going to use this one here. Plug in 2 for y. So 3x plus 4 times 2 is 11. Some of you might have just written 8. 3x plus 8 is 11. Subtract 8 to each side. 3x equals 11 minus 8, which is 3. Divide by 3, divide by 3, x equals 3 divided by 3, which is 1. Okay? Now, not only are these numbers, these are two lines. This is a line and this is a line. The solution is where the two lines cross. Okay? We're not going to be graphing these, okay? But the solution is where they cross. Now, be careful here. Do they cross at the point 2, 1? Do they cross at 2, 1? No, not 2, 1. 1, 2. How do I know the order? X comes before y. Easy way to remember that? X comes before y in the alphabet, okay? Don't do all that work and say the answer is 2, 1. The answer is not 2, 1, it's 1, 2, okay? X is 1, y is 2, okay? Just, you guys are such a quiet class, you're not going to say anything, most of you aren't. Just shake them, just look familiar, like you did this in algebra. Does that look familiar at all? Do you guys remember it at least a little bit? Yeah. Okay, now if you're sitting there going, sweet, Kale said this is a hard section, okay? This isn't that bad, I remember doing this. These aren't the kinds of problems you're going to be doing. They're going to be a little more in depth, okay? And what I'm getting at, before I even get into the new types of questions, is think very carefully before you answer this. Without a calculator, okay? Without a calculator, which of those problems is harder to do? The first one or the second one? Which one's harder, would you say? The first one or the second one? The second one's harder? No. Okay.
The first one.
I tell you what, though, I disagree. I don't think the first one's harder to do than the second one. I don't know the answer right now. It takes longer. It's like saying, is it harder to count from 1 to 10 or 1 to 1,000,000? It's not any harder counting to 1,000,000. It just takes a lot longer, okay? So the problems we're going to do today are like this. It's going to take a lot more work, okay? It takes a lot longer, a lot more writing, a lot more work. And I will tell you this, it's really, 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 really simple to make mistakes. You got to be very, very, very careful. And show your work. And this is not penmanship class, lucky for me, because my handwriting's probably worse than any of you guys's. But a lot of students struggle with this because they can't even read their own hand. They're just scratching all over the place, and it just looks terrible, and they have a hard time doing these problems, okay? So we're going to dive into one of the problems here in just a minute, okay? What I want you to understand is this is something called the elimination method. Elimination, and the reason is, the first step, we eliminated the x's. They went away. We added these up. They went away, okay? They went away. So we're going to use what's called the elimination method a lot, okay? Let me try one more of these easier problems, and then we're going to dive into the tougher questions. So if I gave you something like 5x minus 2y equals 4 and 3x plus 5y equals what do I want here? I think that's what I want. Okay. Just in case you're wondering how I'm getting, I know the answer right now. I'm starting with the answer, so the answer is going to come out nice and pretty. Okay. So here's what we could do, and I only said this once about 2 minutes ago, and we'll see if you guys caught it or not. Okay. Could I add up the x's and the y's and these? Could I add those up like I did in the last problem? Yeah. I could, but I said this is something called the elimination method. Okay. If I add up the x's, we'd have 8x. We add up the y's, we'd have 3y. We add these up, we get 25. You can do that. But what did I eliminate? Nothing. It was a waste of time. It was a wasted step, okay? So we need to pick one that we would like to eliminate. And it doesn't matter, we can eliminate the x's or the y. The x's or the y's, it doesn't matter. And this is where it gets tricky. And I'm going to say this several times over the next few days is this. Once I have you guys turn you guys loose and have you guys work on these on your own, I really don't want you to work on your own. I want you to work with at least one other person, okay? And what I'm getting at is this. If these two ladies are working together, they need to work together, not just she does the problem and she does the problem and then they compare answers. That's not working together. That's just comparing answers, okay? Because however she might approach a problem, you might do it a different way, and you're both right in the way you do it, but if you get different answers, your work's going to look totally different. What I mean is this. If I choose to eliminate the x's, and I'm working with him, and he chooses to eliminate the y's, we're both okay. But if we don't get the same answer, and I want to compare work, it's not going to help, because our work's going to look totally different, okay? So, I'm going to choose to get rid of the x's, okay? We look at our coefficients, 5 and 3. We ask ourselves, what do 5 and 3 both go into? 15, right? How do I turn a 5 into a 15? By 3. How do I turn a 3 into a 15? Now, hang on a second here. If we do that, we're going to get 15 and 15. I don't want 15 and 15. I want 15 and what? What cancels with 15?
Negative 15.
So I need to make one of them negative. It doesn't matter if I make this one negative or this one. It doesn't matter. Just don't make them both negative, okay? So I'm going to change this one to a negative. Okay, I'm going to times by negative 3, okay? So if we times these, we're going to get negative 15x. Negative 3, we times everything on top by negative 3. Everything, even this 4. Negative 3 times negative 2 is positive 6y. Equals negative 12. Good. Now we're going to times the bottom by 5. 5 times 3 is 15x. 5 times 5 is 25y. 5 times 21 is 105. Now what's the benefit? Now when I add them, the x's are going to be eliminated. They're going to go bye-bye, okay? We add these up, they cancel. We add these up, we get 31y. We add these up, and we get 93. Negative 12, 105 is 93. Divide by 31, divide by 31. That turns out to be a nice number, 3. We all done?
No.
How come? Got to find x. How are we going to find x? Plug in 3 for y into which equation?
Either one.
You said either. Not even either. We don't have 2 to choose from. We actually have 4 to choose from. Any of these 4. I almost never pick these 2, though. You can. I almost never do, though, because
They're bigger numbers.
what's easier to work with, bigger or smaller numbers? Smaller. And I'm going to use this one as opposed to this one. These have a little bit smaller numbers, but you know what? Most students get tripped up by a lot in this class. Negatives. I would avoid negatives whenever possible. Is it wrong to pick this one? No. Is it wrong to pick these? No. You pick whatever one you want. I would suggest using 3x plus 5y is 21. And we now know that y is 3. So we plug in 3. I'm going to skip a step here. 5 times 3, I'm not going to write 5 times 3, I'm going to write 15. It's 21. We subtract 15, we subtract 15. These cancel. 3x is 21 minus 15, which is 6. Divide by 3, divide by 3, whatever that is. X is 6 divided by 3, which is 2. So, the answer is 3, 2. Yes, ma'am? Very good. I did that on purpose. Sometimes I make mistakes on accident. Did that on purpose. I hate it when students do this. They do all that. If I do this, do I know what I'm doing?
Yeah.
Do I get the right answer?
No.
If you do, now the thing that's nice about a written test, if you do all this work and you write down 3-2, are you going to get full credit? No. You're going to get most credit, you think?
Yeah.
If it's a 5-point question, I'm giving you 4 points, okay? But the computer, it's either right or wrong. There's no partial credit on the computer. It's wrong, okay? So just make sure you put them in the right order, okay? I hate it when students do all that work, do everything right, then just screw it up at the very end, okay? So that does look a little familiar. I heard somebody say that. It sounds okay. These are still not the types of questions we're going to be doing yet, okay? And again, right now, we're doing problems where you count from 1 to 10. We're going to be doing problems where you count from 1 to 100, okay? It's the same thing, okay, but it's just going to take longer, okay? So, let's go ahead and put this up on the screen. Okay. Now we said before, I said, what's the answer to this problem? X plus y is 10, and we said you can't do that. There's 2 variables, we need 2 equations, okay? Well, problems you're going to have are going to have 3 variables. So how many equations are you going to have?
I'm confused.
Yes, sir.
On that one, how do you divide 3x by 6?
No, I divided by 3. It was 3x equals 6. I divided by 3. Okay. All right, so you have 3 variables, so you need 3 equations. If we had 4 variables, you'd need 4 equations. We won't do those, okay? Those aren't any harder either. They just, I mean, again, it's easier to make mistakes though, okay? So, this may sound really, really stupid, but first thing you do is write down the problem and write it down correctly, okay? If you write it down wrong, it's really, really, really hard to get the right answer, okay? Almost impossible. So I'm going to tell you right now, don't be offended by this. I'm not going to treat you like little kids. But in the next few days, when you start working on these on your own, if you need help, you know what the first question is going to be to you? Did you write the problem down right, okay? Because if you didn't, right from the very beginning, we're basically going to be lost. So let's look at problem number 3. This is actually from the section 1-4, okay? So they give us x plus y minus 2z. I always put lines through my z's so they don't look like 2's, equals 5, 2, and 9. And please do me a favor, if I ever write down a problem wrong, please tell me, and tell me right away. Nothing frustrates me more than when I write down a problem wrong and I work through the entire problem, and then somebody says, oh yeah, I was going to tell you wrote it down wrong, we have to spend 10 minutes doing the problem. So tell me at the beginning if you can. I'm not going to take offense. Negative x plus 2y, negative x plus 2y plus z, and then minus z. Now I am going to give you little tricks, 2x plus 3y, that will help you make it easier, okay? I'm not going to say these are easy by any means. They are not easy. They take some work, okay? So, x plus y minus 2z is 5, 2, 9, negative x plus 2. Is it correct?
Yeah.
Okay, thank you. Just want to make sure. And I'm going to go through this real slow. I'm not going to speed through this, okay? Because it can lose people really, really quick. Now, I gave you the thing where I said K.O. equals Neil and Grady equals Garrett, and let's just say that Bob equals Steve. I don't know who they are. I just made up names here. Could I add up all 3 names and all 3 names and equal each other? Yeah, I could do that. I could.
It doesn't
Could-
work out.
What's that?
It doesn't work out.
Well, okay, it could at times. I wouldn't do it. I really wouldn't. We have 3 equations. I would always take them 2 at a time. Now let's get very basic here. To make it easier, I'm going to refer to this as 1, 2, and 3 equations. And I would do the same thing. Equation 1, equation, and I'm going to circle them. That way you know it's just labeling it equation 1, equation 2, equation 3. Okay? So, the next thing, we have to either eliminate the x's, or the y's, or the z's. Now, whatever we choose to eliminate, we're going to stick with that, okay? We're not going to start out eliminating x, then later on eliminate the y, and so forth. We're going to eliminate x until we're done, okay? So, it doesn't matter which one we eliminate first. But what you want to look for... What's that? Why is that?
Well, there's no numbers. So you don't know.
Well, there's numbers in front. There's ones. And there's numbers, ones. I'm not saying no, but what you want to look for, that's not a bad idea, and we may do that, okay? I would look for a variable that's just x, or just y, or just z, okay?
So X.
Huh? Why do you say x?
Because there's 2 of them that are just.
There's an x and a negative x?
There's also a z.
There's also a z and a negative z. Now, there's a y right here, but there's only one of them, okay? I mean, you could do that, okay? We can either eliminate the x's first or the z's first. You initially said z's. I'm not going to argue with you. I'm good with that. I would probably, if you would have said the y's, I would have been, it's a little bit more work with the y's, but I would say it's equally good to do the x's and the z's. Here's what we're going to do. Whoever speaks up, that's what we're going to do. What do you want to do? You spoke up first. You want to do the x's or the z's? I really don't care.
Let's try the Z.
The z's. Okay, he wants to do the z's first. Now, this is exactly what I was talking about if you didn't understand a few minutes ago, okay? Let's say me and Garrett are working together on this problem. He decides to eliminate the z's first. We're sitting next to you, but I'm not paying attention. I do the x's first. Now, who's right? We both are. But if we finish the entire problem and our answer's not the same, and I look over at your work, it's not going to get anything like mine. It's not going to help because the work's going to look totally different. We approach it from a different way. He said z's. What's the easiest way to eliminate the z's? We have 3 equations. We're only going to work with 2 at a time. Which equations, can we put 2 equations together right now to eliminate the z's? 2 and 3. If I add equation 2 and 3, they go away. So I'm going to put 2 plus 3. Okay? All right, so let's add 2 and 3 together. The x is, what's a negative x and a positive 2x? X. 2y and 3y? 5y. Z and negative z? nothing, equals 11. 2 plus 9, 11. Somebody just knock.
Yeah.
Okay. Now, see if you guys caught this from a few minutes back.
I accidentally came to this too.
Oh, I was wondering where that came from. Okay. How do I solve this equation? X plus 5y equals 11. How do I solve that? Why? Who said that? Why can't you solve that? You're right, we can. Not yet. How many variables are there? Two, which means we need two equations, okay? So here's what we need to do. We need to come up, we started out eliminating the z's. We're going to stick with eliminating the z's. We're not going to change that, okay? You said the easiest way is to add 2 and 3 together to eliminate the z's, okay? We need to pick a different set of two equations to eliminate the z's. Stick with eliminating the z's, okay? So do you want to use 1 and 2 or 1 and 3 now? It doesn't really matter.
1 and 2 because one's a negative, one's
That's a great answer, okay? Is it wrong to say 1 and 3? No, but it's a little bit easier if you chose 1 and 2 because one's positive, one's negative. Now, do we want to add 1 and 2 the way they are right now? Will they eliminate if I add these up?
No.
One's positive, one's negative, but they won't eliminate.
Yeah.
This is a negative 2. I would love for that to have what in front of it?
2.
So I'm going
So
to
you have
put
to
in
multiply.
parentheses a 2 right here. We're going to times everything in this second equation by 2. And I'm going to write it off to the side here, okay? So my negative x becomes negative 2x. My 2y becomes positive 4y. My z becomes 2z. And don't do this. A lot of students will put 2 down. Not 2. 2 times, you got times everything by 2 equals 4. All right? Now, just to make it a little bit easier, it's a little more writing, but I'm going to write down the first equation again. X plus y minus 2z equals 5. What is nicer now?
You can take
We can do what?
eliminate the z's
The z's if we do what?
if we add.
If we add them together. So right here, I'm going to put down 1 plus 2, and I'm going to add these up, and I'm going to write it over here. X in negative 2x is a negative x. Y in 4y is 5y. The z's add up to nothing. Equals what, 5 or 4? Or neither? 9, 5 plus 4. Now, we had these 3 equations with 3 variables. Now we have a subset of 2 equations with 2 variables. Is this solvable now? Yeah. We said before we couldn't solve this because we had 2 variables. We said we needed 2 equations. Guess what? We got our 2 equations now. Now, hopefully, if you can see this, fantastic. If not, it's not the end of the world. Question?
Yeah, I just got a little lost for a second. So
Okay.
the 1 and 2 is how, or that came from solving that right there.
We added 1 and 2 together, but before we added them together, we times this one by 2.
Okay.
That's
so-
why I recopied 1 again, and I times this by 2, negative 2x, positive 4y, positive 2z equals 4. I added these together to get this one. Okay? That's a great question.
So
Okay. And that's exactly what you need to do. If you ever get lost, don't be afraid to raise your hand and ask.
1x minus 2x. Is that how that goes?
Yeah, 1 and you said minus. Just want to make sure you understand. When I said Kale equals Neil equals Grady and Garrett, I said, could I add these up? Could I also have subtracted them? Yes, you can. But just to make it easier for you guys, always add. Just always add.
So
Okay?
1x
So when you said subtract, I'm going to say no, we're adding. Okay?
so
Just
1x.
negative 1x.
Oh,
1 and negative 2. You gain a yard, you lose 2 yards. You've lost 1.
yeah, so you have 1x.
Negative 1x. Or 1x minus 2.
Yeah.
Plus negative 2x. Now you got me saying minus. Okay? 1 and negative 2 add up to negative 1x. Now, what I was saying was this. Hopefully you can see this. What do you think we should eliminate now? We've eliminated the z's. Would it be easier to do the x's? Could I just add them up right now?
Yeah.
Yes, if we add them up. Now, is it wrong to eliminate the y's? No, but it's a little more, not much, but a little more difficult. So if we add these up, I'm not going to write it, and don't put any x's down. There's no x's. Don't put x down, because x is 1x.
0x.
I mean, if you want to put 0x, but just don't even put that. Don't even put 0, just nothing. Let's put down 10y equals 20. We added up the x's, they went away. We added up the y's, okay? Then we divide by 10. and we get 2. What's 2?
Y.
I'm not going to mark you wrong on a written test if you don't do this, but is that important information you think y equals 2?
Yes.
Circle it. There's enough stuff you got on your paper. You know, that's important stuff, okay? Now, are we done? No, because we have to find x and, not or, and. X and z. Now, which do you find next? It doesn't matter, but it's easier. We've been working this way. Work in reverse, okay? We have y equals 2. We work in reverse. What do you think we'll find next? The y's or the z's?
X.
Or, I'm sorry, the x's or the z's?
X.
X. How come you're not going to find the z's here?
These aren't right there.
There ain't no z's. You can't solve for z. It's kind of like this right here. Who can solve that problem?
Nobody.
Really? No, no,
Actually,
no.
no, never mind.
You better go talk to Ms. Gertler and transfer out of here. We can't solve it. Now, who can solve that for x? Nobody can. Why?
Because no.
There's no x. Now, hopefully you can solve for y, unless you're Garrett. Okay? You better be able to solve that, or yikes, it's going to be a long year if you can't solve that problem, okay? So, let's plug into which equation do we use? Does it matter? I'm going to use the top one. X plus 5y is 11. But what do we now know?
That Y.
Y is 2, so let's plug in 2. I'm going to show all my steps here. I'm going to write x plus 5 times 2. If you just want to put 10, that's okay. X plus 10 equals 11. Minus 10, we get x equals 1. Okay, any questions on that problem?
That was only one.
Okay, number 5. Very good, say it.
Don't we have to
We
say
done?
Z? No.
We still have to find z. We gotta find z. So, can I use one of these equations to find z? No, why?
Because they don't have Z in them.
So we have these. Which one do I have to pick?
It doesn't matter.
Which one?
Last one.
You have to pick the last one? Anybody disagree?
You can pick any of them.
You can pick any of them. If you want to pick the last one, that's fine. Okay? What the heck? We use the last one. No, I don't like the negative. I'm going to use the second one. Negative x plus 2y plus z equals 2. Again, it doesn't matter which one you pick, okay? We know that x is 1, so negative x is negative 1 plus y is 2, so I'm going to put 2 times 2. If you just put 4, that's okay. Plus z is 2. Okay. So we have negative 1 plus 4 plus z is 2. 2 times 2 is 4. Put together negative 1 and 4, that's 3 plus z is 2. Subtract 3, z is 2 minus 3, which is negative 1. So the answer is, what, 2, 1, negative 1?
1, 2, negative.
1, 2, how do you know what order you put them in?
Because it tells you the solution is X, Y, Z equals.
Yep. And I'll tell you what, on your written test, it's not going to say x equals y equals z equals. It's, how do you know it goes x, y, z? Because that song you learned in elementary school probably, right?
X, Y.
The ABC song. So 1, 2, negative 1. Fun stuff. Now if you're sitting there going, what the heck just happened here, okay? It's okay. It's the first question, okay? My goal is that when you leave here, you're like, I kind of get it, but, you know, you just got to be very, very careful, okay? You throw in a negative sign where it doesn't belong or leave one out, everything goes to heck, okay? All right. Let's try at least one more question. Number 5. Oops, where are we? Okay, so we have 2x plus y minus z. 2x plus y minus z equals 9, negative 17 and 4. 9, negative 17 and 4. And negative x plus 6y. Does that say 2z at the end?
Yeah.
Plus 2z? 5, 7, and 1. 5, 7, and 1. 5x plus 7y plus z equals 4. Good. Okay. All right. So again, make sure you write down the problem correctly. And this is what I was talking about. try to, I mean, I'm not gonna grade you on penmanship, but just try not to, you know, have some sort of order to it. You don't have to have good handwriting, just still be able to show your work and be organized, okay? Because these are confusing enough. If you just start, you know, writing stuff here, then here, then here, just all over the place, you're just making it more confusing, okay? All right, so what do you want to eliminate first? The X's or the Y's or the Z's? And let's label these 1, 2, and 3. What do you think we should eliminate first? The X's or the Y's or the Z's? Yes, sir.
Z's again?
I would say the Z's. Why?
Because they have a license.
There's 2 of them that are just Z. The Y, there's only one that has just Y, and there's only one that has just X. I say negative X, but just an X. And the reason is this. There actually is numbers in front of those ones. And the reason why you want to pick those is, what does 1 go into? Just 1? 1 goes into, somebody said it.
Everything.
Everything.